So whenever it talks about a tangent line or slope of a tangent line, tangent is a keyword saying find the derivative. The first thing to do is find the derivative, and the derivative will give us the slope of this line. Then we could use the point slope formula to find the equation of it. So we need the derivative, so it's going to be 4x cubed plus 4x, and then the last one, the derivative of x is 1. Since that's negative, it's going to be subtract 1. The next thing to do is find out at that particular point how much is the slope of the tangent line. So the derivative at 1 is going to be a 4 plus a 4 minus a 1. So the slope is a 7. Then we could use the point slope formula if we had an x and a y value. So for this x, we need a y value. So substitute a 1 into the original problem, and that would say 1 plus 2 minus 1. So the 1's would cancel, leaving that y is equal to 2. Now we have all the parts we need, the slope and the point. So the point slope formula would go y minus the y value equals slope times x minus the x value. Or if you distribute the 7, this is going to be 7x minus 7. And if you add 2 to a negative 7, it's going to be only a negative 5. And then I can even graph and verify. So the original problem said x is raised to the 4th plus 2x squared minus x. Take a look at the graph, see if it shows up. Now when x equals 1, so that's this area right in here, so actually I could zoom into that area right about there and see what's going on. And then if I also graph the equation of the tangent line, 7x minus 5, what should happen is it should touch the graph at that one point. So right here at x equals 1, trace x equals 1. So in here, the line is getting closer and closer to the function. This is actually the only place it touches it, and then the two begin to separate again. So if you zoom in very close to that area, there's very little difference between the function and the line.